So today's topic is cross slope or camber. This cross slope or camber, this is one of the part of our highway geometric element. Already in the last class, one element has been discussed, that is pavement surface characteristics, and under this highway cross section elements, this is our second, that is cross slope or camber. One of the important element in the highway. What is cross slope or camber? As per definition, the cross slope or camber is the slope provided to the road surface in the transverse direction to drain off the rainwater from the road surface. Cross slope or camber is the slope provided to the road surface in the transverse direction to drain off the rainwater from the road surface. Drainage and quick disposal of water from the pavement surface by providing cross slope is considered important. Okay. This is the actually our cross slope or camber, the slope which is provided on the road surface to drain off the rainwater, because already I have said the rain or moisture or water content is harmful for our road or pavement. So less water content, more durability of the pavement or our road. So to prevent from the water content or from rainwater, we should provide this kind of slope on our road surface. During construction, normally we can make this shape, the top surface of our road like that. So easily water can drain off from the road surface, and sometimes I already said that the drain also important with road. Along the road we should provide drain or drainage system so that the water can easily drain from the our road. Okay, so as soon as possible, if we could drain off the water from the road surface, so our pavement or our road will be protected from the moisture, because actual where we are constructed our road on earth surface, on earth, and the first layer of the road or pavement is subgrade, which is made of the soil. So to maintain the density of the soil or the unit weight, to maintain the unit weight of our soil, water content, balance of water content, balance of moisture content is necessary. Okay, so if we provide or if we allow more water to the soil, then our soil will get easily moistured or easily get saturated for the water, presence of water. So our work is how can we as soon as quickly can drainage or can drain off the water from the road surface. This is our main objective during road construction or pavement construction. So to prevent the entry of surface water into the subgrade soil through pavement, the stability, surface condition and the life of the pavement get adversely affected if the water enters into the subgrade and the soil gets soaked. This is the actually condition if when the water enters the pavement or enters through the pavement and is directly reached, it is reached to the our subgrade which is made of soil, and this layer, that is subgrade layer, the soil layer, easily adversely affected if the water enters in the subgrade and the soil gets soaked. To prevent the entry of water into the bituminous pavement layer as continued. Yes. Oh, sorry. Ah, okay. Still now, have you listened anything? Have
Yes, sir. No, sir.
oh
No, sir.
no sir no nothing.
No, sir. No, sir. Nothing. You were not audible, sir.
Okay. I am repeating again. What is cross slope? Okay, what is cross slope? Cross slope or camber is the slope provided to the road surface in the transverse direction to drain off the rainwater from the road surface. Okay, so normally the purpose of providing camber or cross slope on the road surface is the to drain off the rainwater from the road surface. Okay, because the drainage and quick disposal of water from the pavement surface, providing cross slope is considered important because of some reasons. What are the reasons? To prevent the entry of surface water into the subgrade soil through pavement, the stability, surface condition and the life of the pavement get adversely affected if the water enters into the subgrade and the soil gets soaked. Number 2, to prevent the entry of water into the bituminous pavement layers, as continued contact with water causes stripping of bitumen. Bitumen can stripped from the material, coarse material or other materials, because bitumen is a binding material which is normally used for binding the coarse aggregates, fine aggregates which are normally used for road construction. So if we not able to prevent the entry of the water in our pavement layer or in the subgrade layer, so easily these kind of things can be happened. Okay, so not another thing, already I have said, you don't I think you cannot you could not hear due to some reason. Our subgrade is made of soil. Okay, so due to this soil condition, normally we are maintain some density because our durability, our strength of the soil is the one of the factor to increase the durability of the road. Water is always enemy for the road. Moisture, water, whatever, or your rain, these are the enemy of our pavement or road. So that our objective is how can we prevent, how can we protect our road from this moisture, because already I have said that the subgrade one of the layer, first bottom layer of the road or pavement. If this subgrade gets soaked by the water, then the density of this subgrade will be decreased, and density and strength is related proportional. If density decreased, automatically the strength of the subgrade will be decreased and the load carrying capacity of this pavement will be decreased. Okay, and after that consequently these things will be happen. Suppose to remove the rainwater from the pavement surface as quickly as possible and to allow the pavement to get dry soon after the rain, the skid resistance of the pavement gets considerably decreased under wet condition, rendering it slippery and unsafe for vehicle operation at high speed. So main purpose is how can we prevent or how can we drain off the rainwater from the road surface. What is camber actually? This is actually camber. Okay, this is the shape of camber. During construction we can construct like this shape, and throughout the road road we should provide such type of shape to drain off the rainwater from the road surface. Also, normally what we do, we are provided drain or drainage system along the roadside, because so that the water can easily drain, or water can easily drain out from this road surface. Okay, so drains are provided both side or single side along the roadside to drainage the water, or maybe or rainwater. To drain off the rainwater, we are provided the drain along the roadside, and also we are maintain this kind of shape on the road surface during construction. This is called camber. Also, another type of camber. This type of camber, you can say also super elevation. All you have the super elevation in your physics class in class 12. Also we have the super elevation in our transportation engineering class also. So you will get after 2 or 3 class what is super elevation, the broad idea of super elevation. This is also super elevation, as well as this is also camber. Okay, one side is raised and another is side is down. Elevation of the one side is high, and elevation of the another side is lower than other side. So this kind of construction can be done to drain off the rainwater from the road surface, to prevent our road surface or pavement surface from the rainwater. Okay, this is one of the type. This is one. Actually, this is called camber, and this type of shapes are maintained throughout the length. Okay, suppose you are constructing 50-kilometer road as an engineer, you should maintain same shape throughout this 50 kilometer, or maybe this shape you can maintain as per your design. There, after that, usually the camber is provided on the straight roads by raising the center of the carriageway. This type of raising the center of the carriageway with respect to the edges, forming a crown or highest point on the center line. This is called crown because the center portion is raised and these both sides are down. Okay, at horizontal curves with super elevation, this is at horizontal curves with super elevation, the surface drainage is affected by raising the outer edge of pavement with respect to the inner edge. So in horizontal curve, suppose this curve is called horizontal curve. At this case, the outer portion, this is outer edge, this is inner edge. Okay, this is called outer edge, this is inner edge. So raising this outer edge, we can maintain this cross slope or camber. So at horizontal curves with super elevation, the surface drainage is affected by raising the outer edge of pavement with respect to the inner edge while providing the desired super elevation. Okay, the rate of camber or cross slope is usually designated by 1 in n, that is slope. 1 in n, that is slope. 1 is horizontal, n is the vertical. So 1 in n, 1 in small n, 1 in n, which means that the transverse slope is ratio 1 in n. In camber cases, this 1 is vertical to n horizontal. Okay, 1 in n, that is 1 is vertical to n horizontal. So camber is also expressed a percentage. If the camber is x percentage, the cross slope is x in 100. So if our cross slope is 1 in n, 1 in small n, then 1 is vertical, n horizontal for camber cases, camber or cross slope cases. Also, we can represent the camber as x percentage. Suppose x percentage, then x in 100. Okay, that the representation process. The required camber of pavement depends on one, the type of pavement surface, and number two, the amount of rainfall. So two factors are there. How much raising portion, suppose if we provide this kind of camber, what should be the raising portion? The raising of the crown should, raising value should be what? And if we provide such type of camber or such type of shape, so what should be the outer edge raising? Okay, the rise portion. So this is depends or completely depends on the type of pavement surface and the amount of rainfall. So your payment type of payment surface and rainfall is responsible for the raising portion or the rise of the camber. A flat camber of 1.7 to 2% is sufficient on relatively impervious pavement surface. 1.7 to 2%, that means 1.7 by 100, or no, sorry, 2 2 by 100. Okay, so the flat camber
Sir,
value is, yes, yes,
सर आप जो बोल रहे थे इसका पीपीटी नहीं होगा
आएगा आएगा, रुको रुको, आएगा, जस्ट
सर भूल जाते हैं तुरंत
ना ना, आएगा आएगा, रुको रुको. सो फ्लैट ऑफ, यहाँ पे लिख देते हैं, जस्ट वेट. I'm writing this. The thing is that a flat camber, a flat camber of 1.7% 1.7% to 2% 1.7 to 2% is sufficient on relatively impervious pavement surface. What are the impervious pavement? Like cement concrete or bituminous concrete. These are the impervious pavement surface. For impervious pavement surface, the flat camber value should be 1.7 to 2%. Okay, this is one of the value which can be asked anywhere. So in pervious surface like water bound macadam WBM road, for pervious surface, or the earth road which may allow surface water to get into the subgrade soil. For pervious surface, this is no option. For pervious surface like water bound macadam, some earthen road which may allow surface water to get into subgrade soil. Steeper cross slope is required for earthen slope. So this suppose flat camber, normally flat camber, that means 1.7 to So 1.7 by 100 or 2 by 100 is provided for. Suppose this impervious level. Impervious level is the slope is not very steep. You cannot you cannot feel like after observing that there is any slope. Okay, but after measuring with some instrument, by using some instrument, you can only find out there is some slope. But in earthen slope, in earthen road, earthen pavement, suppose WBM on earthen road, at that cases normally no impervious layer is there, open to environment. At that case the slope or this camber should be steeper. Okay, these value should be greater, but there is such type values are not available for earthen road. Only the impervious pavement surface these values are available, but for pervious layer or for pervious road this kind of value is not available. Only just mention that the camber or the rise portion of the camber should be steeper or the slope should be steeper. So at the same reference, with the same reference, steeper camber are also provided in areas of heavy rainfall. The minimum camber needed to drain off surface water may be adopted keeping in view the type of pavement surface and the amount of rainfall in the locality. Already said, too steep cross slope is not desirable because of the following reasons. Transverse tilt of vehicles cause uncomfortable side thrust. Normally steep camber, the rise very steep camber. This camber is suitable for moving vehicle. But if we provide very steep, slope is very high, okay, that type of camber is not suitable for journey, not suitable for not comfortable for journey. Okay, so all the thrust on the wheels along the pavement edges is more causing unequal wear of the tires as well as road surface. So road surface can harm, tire can harm, so that kind of things can be happen. Discomfort causing throw of vehicle when crossing the ground during overtaking operations. Problems of toppling over high laden block cars and trucks. Toppling problem. Okay, toppling of vehicle, accident, toppling. These are the terms which are used for normally accident cases. Toppling can be happened. Formation of cross darts due to rapid flow of water. Cross darts, that is, water can make channels on the road surface. If you provide very steep camber, channels, various small channels, small some roots can be generated, can be created on the road surface. Tendency of most of the vehicles to travel along the center line. These are the some things. Now after that, these are the shapes of cambers, shapes of camber or cross slope. Another name of the cross slope or camber is cant. Okay. Yes, Utkarsh. Hmm.
Steep का मतलब है
Steep. wait. एक मिनट.
okay
Yes. इसमें क्लियर हो जाएगा. अच्छा, the camber is given in parabolic, elliptic or straight line shape in the cross section. The camber is maybe parabolic, maybe straight line camber, maybe combination of straight and parabolic shape. These three are the shape of cambers. Maybe parabolic, maybe straight line camber, maybe straight and parabolic. Parabolic or elliptic shape is given so that the profile is flat at the middle and steeper towards the edges. Okay, parabolic or elliptic shape is given so that the profile is flat at the middle and steeper towards the edges, which is preferred by fast moving vehicles as they have the frequently cross the crown line during the overtaking operation on two-lane highway. So in the in this figure, suppose okay, if this is the elevation of that portion is high and elevation is at that portion is low, okay, this is called the steep. Normally if raising is happen at the side more than the other side, raising is happen more than the other side, okay, this is called one of the steepest. And same type of camber or cross slope we can provide for two lane or two pavement which are passing at the same place. Suppose two lane road, okay, you know about the two lane road, three lane road, four lane road. जैसे ये national highway, these are our four lane road normally, okay. So suppose one is for up, one is for down normally. So if one road, okay, left side road, suppose when you are going one place to another place, this is left side road, you can provide as an engineer that kind of slope. And another side, for another road you can provide just opposite slope, okay, just opposite slope, same, but your middle portion, suppose you can consider this is one road, this is another road, okay, some barrier or the divergence, if provide some barrier or divergence in between these two lane, then this road also can behave like that. This portion is raising, this portion is down, and also for another lane this portion is left side is raising and right portion is down. Suppose for left lane, again I am saying for left lane right portion is raising, left portion is down, and for right lane left portion is raising, right portion is down. So this crown or this raising portion, if we provide much more elevation corresponding to the edges, these edges we provide elevation, much more elevation or vertical elevation, I can say vertical elevation, then that can be said as a steeper, okay, that can be said as a steeper. Steeper means this slope is high, this cross slope, these are the cross slope. Along the road is longitudinal slope, along the road in the direction of my journey is called longitudinal direction, and the cross our direction, if this is y, if this is x is the cross slope, okay, and this is y is our longitudinal slope or longitudinal direction. If we provide the slope, then longitudinal slope, and if we provide the slope, normally we are provided, if we provide the cross slope or slope in the x direction is called camber. This is the difference, okay. And if we provide more elevation, vertical elevation, then this slope will be very steep, okay. If we provide more elevation in the middle section or center line compared to the edge of this highway or edge of this pavement, then it is called steeper condition, very steeper condition. Advantage of the steeper condition is water can drain off very quickly due to great slope, okay, due to great cross slope, water can very easily drain off, but the disadvantage of the steeper road is water can harm your pavement. So steeper slope is only can be provided for earthen road or WBM road, not for these impervious road cases. For bituminous concrete road, normally concrete, when concrete is used on road surface, at that case we should not provide the steeper, we should provide the flat camber. Okay, as you can see in figure, the figure which I have given, it is example for flat camber. But in the same picture, if we, in the same construction, if we provide the maximum vertical elevation on the middle section, then it could be said as the your steeper camber. Okay, instead of flat camber. Now these are the shape. This is the parabolic shape. This is the straight line camber. This is the combination of straight line and parabolic shape. For parabolic shape, first say straight line camber. That could be easy for you. Suppose the slope is 1 in n. 1 is vertical, n is horizontal. Okay, if 1 is vertical, n is horizontal. This is the slope value. Okay. W, you can see this W is the width of the pavement, width of the road surface width. Now our intention is to find out this crown or raising portion. This is called crown or raising portion, elevation portion, vertical elevation portion at the midsection. This value is needed to find out or to set out. As an engineer, when I am constructing any road, I have to set this value, how much should be this raising portion in the middle section of the road, so that the worker can set or the mistri can set this value for road construction, because I need this slope to drain off my rainwater. Okay, normally this is defined as 1 in n, no problem. 1 is vertical, n is horizontal. Now the formula is half of the width of the road is W by 2. Okay, now simply multiply this W by 2 into 1 by n. Suppose my slope is 1 in 20. Say 1 in 20. 1 in n means n instead of n, n is the representation. So 1 in n, that is I have taken 1 in 20 for my road construction. 1 in 20. So this elevation or this raising portion of the mid section of this road should be, another value is needed. This is W. What should be that? Suppose W of my road is 3.8 meter. Suppose 3.8 meter is my width of the road and slope is 1 in 20. Then what should be this height of this crown? What should be the height at the middle section of the road? W 3.8 by 2 into, instead of n I can write 20 because my slope is 1 in 20. So 3.8 by 2 into 20, that is meter. That is my height at the midsection or crown of my camber, or the raising portion of my camber, or the vertical elevation of my camber. Okay, this is the simple simplification of my camber. This is the straight portion. But if my camber is parabolic shape, in that case something is required. What are these? These are parabolic. Suppose parabola. For parabola case, there is one formula, that is y equals to, or the equation, that is y equals to x square by a. Okay, y equals to x square by a. So normally if you see something is given in the figure, same W is my width of the pavement or roadway, and this parabola is defined by y and x is the horizontal, y is the vertical, and thus if we draw the straight line with parabola, this straight line, some slope is there, same like straight line camber, and this slope is defined as 1 in n, same as straight line camber. So y equals to x square by a, this is the equation of parabola. Now x is this, and you need to find out a. Normally, as per equation, a equals to n into w by 2. Okay, a equals to n into w by 2. Therefore, if we put this a value in this equation, y equals to, in this parabolic equation, y equals to 2x square by nw. This is our formula y. And what is this y value? Y value is nothing but y is my this crown value. Okay, this crown value for parabolic shape camber. This crown value, this vertical raising portion of parabolic shape camber. In parabolic shape camber, this equation is normally used, y equals to 2x square by nw. Okay, acha. One numerical is there. Also some values are also there. You should see for values. These are the values, recommended values of camber for different types of road surfaces. Suppose type of road surfaces and range of camber in areas of rainfall range. Suppose your type of road surface is cement, concrete, and high type bituminous surface. Okay, then, and if the range of the rainfall is heavy, the camber value should be 1 in 50. Or 2%. 2% means 1 in 50. 2 by 100, that is 1 by 50. 1 in 50. And the rainfall, if rainfall is light, then the camber value should be 1 in 60. That is 1 by 1.7. 1.7 by 100, that is 1 in 60. For thin bituminous surface, this for heavy rainfall 1 in 40. For light rainfall 1 in 50. For waterbound macadam and gravel pavement, the range of camber in heavy rainfall 1 in 33 and light rainfall is 1 in 40. For earthen road, this for heavy rainfall 1 in 25. For light rainfall 1 in 33. You have to keep in your mind, or you have to always by heart these values during exam, because these values are not will not be provided in your exam. You should keep in your mind what should be the value for cement, concrete, and high type bituminous surface for heavy rainfall, for light rainfall. For bituminous surface, what should be the value for heavy rainfall, for light rainfall, what should be the value for waterbound macadam, or for gravel pavement. For earth surface, what should be the value for heavy rainfall, for light rainfall. These values should be by heart, by yourself. 1 in 50, 1 in 60, 1 in 40, 1 in 50, 1 in 33, 1 in 40, 1 in 25, 1 in 33. To solve numerical, camber related numerical, these values are required, because depends on your rainfall and the type of surface, your crown value or raising portion at the mid section of your road will be selected. Okay, will be designed. Suppose one problem is there in a district where the rainfall is heavy, major district road of WBM pavement. Okay, 3.8 meter wide, and a state highway of bituminous concrete pavement 7 meter wide are to be constructed. What should be the height of the crown with respect to the edges in this two cases. So one is WBM road and another is bituminous concrete pavement. For this major district road, the width is 3.8 meter, and for this state highway, the width of the road is 7 meter. Now, as an engineer, what should be the height of the crown or this vertical elevation with respect to the edges in these two cases? Now, this solution is for WBM road cases. From this figure, we can see we have two options. One is we have two questions. One is for water macadam road and another is for bituminous road. For water macadam road, the heavy rainfall value, if we take the heavy rainfall value, suppose 1 in 33, it will be safe for in our design. It will be safe for the road. So normally we have taken the heavy rainfall values if not mentioned in the question that heavy or light rainfall. Always we take the heavy rainfall case 1 in 33. Suppose 1 in 33 for waterbound macadam road or WBM road. Okay. So in question, as per waterbound macadam, the heavy rainfall is 133. I know the value 133 and the width is given in question 3.8 mm a meter. Now just simply remind this thing W by 2n. Okay, W by 2n. Now put this formula. W is your 3.8 divided by 2 into 1 in 33, 1 by 33. This is your the height of this crown. Okay, 0.058 meter. And second case, the road is bituminous and I should check road is bituminous and bituminous surface they have mentioned in rainfall in these two cases. District where rainfall is heavy, major district road, heavy rainfall. Both the cases they have mentioned heavy rainfall. No problem. For heavy rainfall the road condition is bituminous concrete pavement. For bituminous concrete, not only bituminous concrete, that is high type bituminous surface. So for heavy rainfall this value is 1 in 50. So in solution we should take 1 in 50. Okay, same formula, W by 2 into 1 by n. W is 7 by 2 into 1 by n, 1, n is 50, so 1 by 50. So our value is 0.07. This value, this raising value. Okay, you should please take a screenshot of this slide, these two slide, the question slide, and you have to send me back in my mail. All of you please solve in using pen and paper. Solve by pen and paper and please send to me as a assignment. Okay, please take screenshot of this slide in district. This is the question and this is the solution. Take screenshot. You have to send me back. Yeah, yes. Yes, please. I am not getting you. This is the question. This is question. Yes, you should write question. You should write question. This is the question. Please take the screenshot and this is the solution. Okay.
Sir, please click on page number 44, sir.
Page number. This question from your Khanna Jastu book. I have old book. You can take from Khanna Jasta book also. Okay. This. This is not important. This is important. This is important. Okay. After this camber, there is width of pavement. Okay. Width of pavement. Width of pavement or carriageway. Under the your these cross section elements of highway. First was pavement surface characteristics, then cross slope or camber. Third, width of pavement or carriageway. Width of pavement or carriageway. Width of pavement or carriageway. Normally, the width or the pavement or carriageway width depends on the width of traffic lane. Okay, width of traffic lane, this pavement or carriageway width depends, and number of lanes. The carriageway intended for one line of traffic movement may be called a traffic lane. The lane width is determined on the basis of the width of vehicle and the minimum side clearance, which may be provided for the safety. So, important factor to determine the width of the pavement or carriageway. Okay, width of the pavement also called, it is also called carriageway. So, this width of the pavement or carriageway depends on the width of the vehicle width. So, vehicle width one of the important, and the clearance. Only vehicle width is not important. Along with vehicle width, the clearance from the vehicle is also important to determine the width of the pavement or to select the width of the pavement, or the suppose you are constructing road, suppose you are constructing pavement. So what should be the value, what should be the width of your carriageway or your pavement or your road? It totally depends on the width of the vehicle or and clearance. So when the side clearance is increased, suppose up to a certain limit, there is an increase in operating speed of vehicles. Side clearing is more, operating speed will be increased, because without tension you can operate the vehicle if your side clearance is maximum. But when side clearance is less, the operation of the vehicle is very difficult. You should be you will feel some fear to operate your vehicle. But the clearance is maximum, then easily you can operate your vehicle. Okay, so the width and side clearance obviously for safety purpose also is important to determine the width of your pavement or carriageway. Keeping all this in view, a width of 3.75 meter, I think it is not visible in this, I am writing here, 3.75, very important data, 3.75, 3.75, 3.75, right. 3.75 meter, 3.75 meter. Normally we are provided 3.75 meter for single lane. This value is specified by our researcher, Indian researcher. The width of the pavement should be 3.75 meter minimum width to operate our vehicle smoothly with proper side clearance, with maintaining proper safety. The width of a single lane should be 3.75 meter as per Indian scientist, Indian researcher. Okay. So 3.7 meter is considered desirable for a road having single lane for vehicles of maximum width 2.44 meter. So if your vehicle width is 2.44 meter, normally our vehicle width is maintained 2.44 meter in India, or simply we can say 2.5 meter. So if our vehicle width is 2.5 meter, then our road width should be 3.75 meter for single lane. Okay. For pavements having two or more lanes, width of 3.5 meter per lane is considered sufficient. So when for suppose national highway, we are providing number of lanes, okay, 4 lanes, 6 lanes. So that kind of situation, for that kind of situation, we can provide 3.5 instead of 3.75, because when number of lanes are maximum, then the width of the pavement can be maintained with 3.5 meter. That's not a harm, because your lane is maximum, number of lane is sufficient, then you can decrease your width of the pavement, and it is restricted to 3.5 meter. The maximum width of vehicle as per IRC specification is 2.44 meter. This 2.44 meter is specified by IRC, the width of the vehicle. Okay, or simply we can say 2.5. No problem. For details, we can refer Art 5.2, or sorry, Art. For details, we can refer Art this 4.2. Okay. And if a single lane carriage of width 3.8 meter is provided, 3.75 is round figure is 3.8, suppose 3.8, 3 meter is provided, a side clearance is 0.68 meter. Okay, 0.68 meter or 0.6 uh, in figure 0.625 is showing, but as per IRC 0.68 meter, as per IRC 0.68 meter uh, should be taken, or 0.6 meter would be obtained. Okay, in the case of two lane pavement of width 0.7 meter, if this is for single lane. Okay, also the writing is not clear, so I am writing here again, for single lane, for single lane, single, wait, for single single single. Okay.
Sir, single lane means up down.
Single lane, up without any barrier, without any barrier, the when road normally constructed without any barrier. Suppose if you get this, if you want to see the direct example of this single road, that is Fuljo to our college, that is single lane road. Okay, that is single lane road. Only one vehicle can easily move without any difficulty. Okay, but the Fuljo to Steel Park Road, suppose Fuljo to Bhagat Singh, Fuljo to your government college. Okay, this road is two lane road. Okay, but the divider is there. In divider, on that road, divider is there, but without divider also we can construct road. Okay, without divider also we can construct road. If divider is not provided, then the road Fuljo to your government college road can be said as two-lane pavement. Two-lane pavement. But also with divider also we can say that is two-lane road. No problem. So single lane road, for single lane road is with this 3.75. Side clearance as per IRC 0.68, and the vehicle width should be 2.44 or 2.5. As per IRC 2.44, but we can take 2.5. And finally the round figure of the road should be, or maybe 3.8 meter, no problem. But in case of two lane pavement with this 0.7 with this 7 meter, a minimum clearance between two lanes of traffic would be 1.06 meter for the widest vehicle on the road. 1.06, the minimum clearance between two lanes 1.06 or 1 meter, simply 1 meter, no problem, 1 meter. Okay, in figure 1 meter is given, 1.06 or 1, whatever, for the widest vehicle on the road. The number of lanes required in a highway depends on provided traffic volume and the design traffic volume of each lane. The width of pavement is increased in horizontal curves are introduced, and it will come, no problem. In some highways, traffic separators or medians are provided. Traffic separators, medians will come in next class. What is traffic separators, what is medians, which are provided between two sets of traffic lanes intended to divide the traffic moving in opposite direction. In such highways, the road width depends on pavement width. Okay, and the width of traffic separators, the width of carriageway for various classes of road restricted by Indian road codes are given in this table. Just see this table. This is the width of carriageway. Normally, for single lane roads, the width of carriageway should be 3.75 meter. For two lanes with raised curve should be 7 meter. For two lanes with raised curve should be 7.5 meter. Intermediate carriageway, except on important roads, is 5.5 meter. Multi-lane pavements 3.5 meter per lane. These are the some values of width of carriageway and provided by IRC. Okay, so that's enough for today. Just wait, don't leave. I am taking attendance. By today, please send me the assignment. Okay, this assignment. Okay, and another thing, already you have books. Kannadastu book. Have you downloaded?
Yes.
Ebook. So you can follow the book. I have taken all these things from Kannadastu book. All these things, all these values from Kannadastu book. You can very easy book, very simple book. You can follow, no problem. Okay, thank you. Thank you.